Record. Hello, welcome everybody. Thank you for joining. Today we're going to be covering performance schema. I want to start out with a demo, and then maybe we'll talk a little bit of theory because I want to show how it's improved over the years as your impressions with it may be outdated. I'm personally a fan. I love it, and I think what made me think of this most recently is I was working with a user in Canada that had all this load related to the current health situation. And I didn't have access to the server, but I said, just give me performance schema dumps, and I was able to diagnose quite a bit. So it kind of refreshed my love of performance schema, and I wanted to share that enthusiasm. So thank you for joining, and please ask questions as we go. I want to start with the very simple version for me of what performance schema is. And so I have MySQL 8 here. I'm going to use the sys schema, and then I'm going to just show you a set of tables that are available. So the X ones show the raw, unformatted data, and the other ones show sort of summarized in human form. If you first log into a server, what I want to encourage you to do is to select star from statement, or let's do it from the full version so nobody gets confused. Statement analysis, and you will get a summary of the slowest queries that are on your system. So it's ordered by what is the most expensive first. So in this case, my server has just started up. So it says that this was the most expensive query. It's been executed 6,000 times. And the total time, if we aggregate those 6,000, was that it took 497 milliseconds. So I want to do a quick exercise, and I want to show you how this data is live. And we'll select sleep 10. And then I'll repeat the query again, and we should see that immediately we now see what our top query is, ordered by that aggregate time, should be this sleep query. Let's do a limit one so we don't have to scroll back so much. Okay, and we can see the total time was 10 seconds, the execution count was 1. This is what I meant by it's using the human form. If I did select star from sys.x dollar statement analysis, I would see this in the raw time that I could use for an application if I wanted to put a GUI on top of it. Another one that I want to show you inside of sys, and then we'll explain what sys is to say select star from sys.session. And you can see everyone who's currently connected to this server and what they're doing. It's very similar to something like MySQL process list. This is my particular query, but it shows you a lot more information. Okay, so what I want to explain with these two demos is that performance schema doesn't have to be hard. I think of performance schema as very similar to something like the proc interface on Linux, where it's got all of this raw data, but there's human versions of it, like if we use the Linux example, there's vmstat and iostat, and this is what sys is. It's a level of DBA views on that raw information. It's also possible, because performance schema presents itself like a regular table, that third parties, such as myself, may distribute queries that you can execute. If you go just directly to the performance schema, which you'll see in show databases, I mean, these tables are a little bit complex to be able to understand all of them. And I don't think that's a requirement. You certainly can, but I think there's a lot of value in performance schema in sys in particular, because it provides those common aggregations. And I find sys session more useful than show process list in particular. Any questions so far, or agreements, disagreements from the peanut gallery? Thumbs up. Okay, so that's my starting point. Let me go to my notes, and let's talk a little bit about performance schema, some of the implementation in the history. So performance schema, the developers often abbreviate it to PFS, and then there's sys. Sys was a later addition to performance schema. It had an addition that you could download separately for MySQL 5.6, but it shipped by default with MySQL 5.7. So it makes it very easy to be able to view that information in an aggregated, sorted form that's oriented around DBAs. There's some terminology that's useful to understand performance schema. It has a set of instruments instruments is where the measurements are done. And then it has a set of consumers, which you can think of as where the instruments feed the data into to aggregate it so that you can view it in a summarized form. So you may have to turn on individual instruments and individual consumers to be able to see the performance schema data that's useful. Not all of them are enabled by default, but certainly the most useful ones, I think, are enabled by default in MySQL 8. If you're using an earlier version of MySQL, there's a couple in particular that I'd encourage you to turn on. And this is how you do it in your configuration file. So I love seeing memory instrumented, and I love seeing metadata locks instrumented. I think that these are two things that are very opaque in MySQL, and they just become much easier to understand when you've got performance schema. So the next couple of bits of theory, and then we'll show some examples, and then we'll jump back to it on the rest of the history, is that I think performance schema really became useful in MySQL 5.6 because it has instrumentation around queries in what is digested form or the prepared statement form of a query. So, in many of those examples, like where I did select star from sys.statement analysis, it's grouping all of those queries together and replacing out the individual values to summarize it. And this is the terminology used as digest. The raw instrumentation in performance schema is always measured in picoseconds, which is this really obscure unit. I think it's a trillionth of a second. All of the measurements of data are in bytes. That view that I showed you that we're summarizing in a human form, it uses some built-in functions that are now available in MySQL. So you can do something like let's run a very quick query and say select format bytes and some magical number, and then you'll see what that ends up being in a human form. These are built in MySQL 8.0, but it's actually very easy to use them in MySQL 5.7. You just have to prefix them with the sys schema, and they're written as stored procedures. The deprecation warning here just says that eventually this will go away as it's become a native function. Okay, so that's kind of the theory that I wanted to cover. I think it'll help. I want to show you some examples, and the examples are a little bit more custom in some sort of problems that I've solved with performance schema. I will start with one of my favorite ones, which is to show you in MySQL 5.7 how I managed to find a bug. And then I will open it up to your preference for what we should show next. So let's look at this particular one. I always, in MySQL 5.7, enabled the memory tracking in performance schema, even though it was not the default. And what I could see is that when MySQL 5.7 went GA, InnoDB was using a lot of memory in this portion of the code, which was handling files. And this was the default install of MySQL, and it was allocating 600 megabytes of memory. And this is the query that I had to run. All of this is available directly in sys. So I thought, okay, that doesn't make sense. Let's check MySQL 5.7.7, and I could see that it didn't have this file IO as the top item. The top item was the buffer pool, which is somewhat what you would expect. So I reported the bug. The developers said, yes, this happens to be a inefficiency in how the transparent page compression was implemented. They fixed it a few versions later, but for me, I think what's really interesting here is that I don't know how I would have found this data. I would have had to use a profiler or a GDB or something like that to be able to find it. I can do this just built into regular MySQL from a table that exists here, and all I had to do was change one configuration setting, which was this one, which I no longer even need to change in MySQL 8. It's enabled by default. And I think that's just really a success story of what you can do with performance schema. I'll use that as kind of a segue to say what sort of overhead this has. I think the memory off the top of my head was like 1 or 2% of overhead in some very specific workloads where it was allocating and freeing memory a lot. Generally, the goal with Performance Schema is that it is an instrumentation system that's designed for production. It's not like a developer profiler tool, it's a production profile tool. And so the MySQL developers, is, they plan what their correct level of overhead is. They can't turn on all the instruments, but they turn on the ones that are most useful, trying to hit that budget of sort of 5 or 10% to make sure that it's easy to debug the server, but it's not going to take too many resources to be able to do that. Questions? That's sort of my intro. Now I'm ready to jump into examples. So please feel free to vote what you would like me to cover. So we have the choice of, let's close this one, how to look at memory usage, my feature requests for Performance Schema, what's missing, how to see some of our oldest transactions in our system. That's something that's quite opaque in show process list. You don't see the actual transactions, you just see the sessions. And we can look at things like metadata locking. So what should we cover first? Why not all?
I vote metadata locking.
Okay. Yeah, I'm with you on metadata locking, and so is Jacob. This is something that's quite opaque. So in MySQL, you have data locks, and they are called data locks in MySQL 8. There's a table in Performance Schema that's new. It was called InnoDB locks or whatever in previous releases in Information Schema, and you have metadata locks. So data locks protect against someone else modifying the same row, and they're held for the duration of a transaction. Metadata locks, they protect against like the table disappearing from under me while I'm modifying data. So every session is going to require some metadata locks, generally not exclusive locks unless you're doing something like lock tables. And generally you can have a scenario where you have a sleeping connection in show process list and you don't realize that that's the one that issued lock tables. So there's not a built-in view in sys, unfortunately, for metadata locks, and I have my feature request to be able to do that. I will show that to you briefly. But then we will execute it on my running server. So my suggestion, and maybe it's not the ultimate one, is that you should be able to get a view of session, sys.session, which is that example that we showed, and then it should summarize the locks for which we have held in this particular query. And we can see these are all shared locks, as this is just a read query I'm running basically select star from sys.session with that join. But if I were to do something like lock tables in another session, which we'll experiment with, you'll see that we have that exclusive lock. So let's do that. I've rewritten this to be a little bit more human. This is called a CTE. It's a feature of MySQL 8. But from that bug report, you can produce a MySQL 5.7 version that'll work fine. Okay, so let's load up 2 sessions. Oh, sorry, I already started MySQL, of course. I think I have a world schema, show tables, lock. Lock table city. Is that the right syntax? Yes, it is. Okay. And now I'll just paste my example. I think I have to show that in vertical format. What am I doing wrong? User error. Maybe let's just go back to the bug report and we'll get it from there. Don't modify your examples last minute. Okay. Okay, so this is my session. I can tell that because it's joining on this table. And then I can see that I have acquired locks on these tables. These are the tables that I have to access. Basically, it wants to make sure that that is, the rug's not pulled out from under me while I'm reading from those tables. And then we can see in this other session that the last statement that we executed was to lock the table city right. And we can see that we've been granted a lock on this particular table. So if I were to do, for example, show process list, I would not easily be able to see that that's locking, right? This session has been sleeping for 84 seconds. Its state is nothing. What do I know? I don't know that it's actually holding a metadata lock that would prevent me, if I were to go to world, from world, what table was it? City. It would prevent me from being able to run that query. This is why I think it's particularly opaque. But in MySQL 5.7, if you turn on that particular set of instruments, or in MySQL 8, it's on by default, you'll be able to see that this lock has been granted to that particular session. Make sense? I've helped a few users out with that.
Is that a bug that it's not showing anything about that process?
Show process list, it kind of shows what work is being done.
Okay.
In a way, it's not work being done. I mean, it's a lock that's held, and then it's sleeping. And the same is actually true of data locks as well as metadata locks. If I held data locks in this session, I wouldn't be able to see that either. But I think with data locks, we've always had the ability to run show engine InnoDB status, or in information schema, there were some InnoDB lock tables. With metadata, there's been absolutely nothing until instrumentation was added to performance schema. And that's why I stress how useful that is. Because it's easy that a session could have said lock tables, and it could have gone to sleep. That's a good tangent. I want to show you the equivalent or semi-equivalent in data locks. So let's go back to my examples. And I have one for oldest transactions. So this is a very simple view that I created where I said, what's the MySQL process list ID? How long has a transaction been open? How many row locks does it hold? And how many row locks is it waiting on? And then basically summarize the tables that are within that. And so I'll run the query. I think initially we'll get nothing. And then I'll do a bit of a simulation to create a lock. So that's, okay, performance schema. This example is MySQL 8 only. The other one, the previous one, metadata locks, would work with 5.7. So you can see that there's a thread ID 6000. It's held a transaction for just milliseconds. It doesn't hold any locks. It doesn't hold any locks, and there are no tables mentioned. Let's create a simulation. Just to keep things healthy, let's unlock our tables. Start transaction. Select star from city. And this itself won't lock the rows, right? It's going to use MVCC. So let's show an example of that. We'll repeat the same query. But an easy way, other than modifying the data, is we can just save for update. And then we're going to set row locks in each of these rows in this table. Clear as mud. So let's run show process list again. What can we see? Well, it's obviously this one that's holding the row locks. But it's quite opaque, right? There's no information to be able to say that we're holding locks there. We need to be able to run a query like this. For argument's sake, let's use InnoDB status. And we should be able to see that there's a transaction open. It's active 47 seconds. It holds a bunch of row locks. Not so useful, and it doesn't show the table name, right? You can see how performance schema in its structured form makes it a lot easier to be able to be actionable on this information. Questions? A couple of nods.
Do you need to enable these in 5.7?
Do you need to enable it in 5.7? This does not work in 5.7, this one.
Okay, sorry.
Yeah, this one is data locks. So actually, there is some InnoDB lock information in 5.7. It's in information schema. The feature is broken / misdescribed, where it tells you that it'll tell you locks, but it only shows you lock weights. It'll only show you information if basically someone else is being blocked. So it tells you when there is a problem. It doesn't tell you when there's a symptom of problems. If you want to know a symptom of problems, you need to use MySQL8 in this case, unfortunately. And that's the question. Is this information already available in InnoDB locks? Yes, it is. No, it's not. Unfortunately, it doesn't really work the same way. I wish it did. I think information schema, for those who don't understand the historical difference between it and performance schema, information schema, it uses temporary tables internally. It's not implemented as an engine. So storage engines kind of have to fill a data structure and then push to a temporary table for it to work. It's not well suited for fast changing metadata. This is where performance schema is a little bit different in that it uses the engine API. It's easier to just make it a view into the internal data structures, which makes it better suited for when you have this rapid change in metadata. Question?
Yeah. So those that query of yours was able to return. Was that the last query executed by that transaction? And if so, is it possible to see the query that actually did the lock, grab the locks?
Yeah, good question. I don't think it is possible. This is a great question, though, which feeds into my feature requests for performance schema. So, I mean, I'll look back on the end at the end, but I'll answer it now. I like the consumers in performance schema, that, you know, the summaries, in that a lot of them are around the statement and some of them are around the user. I would love more consumers around the transaction level. I think that'd be really useful. Particularly, I have a feature request where you should be able to name a transaction and say, this name is start transaction, you know, food, and that would probably be the name of my controller in my application. And then I should be able to get a dump of all of the queries and all of the time that it took to be able to do that. And then I should be able to get, you know, a query time distribution of those transactions. You know, this is more akin to what the user feels when they use the system than a statement. I would love that. And we could throw locking in there as well. It's not currently quite like that. Maybe someone else knows the answer to that question, but I believe the answer is no, we can't grab it down to the which statement created that lock. Another comment, information schema was re-implemented in 8.0, which improves some of these performance issues compared to performance schema. Yes, that's true. Yeah, so information schema in MySQL8 doesn't quite have that historical thing anymore, in that a lot of information schema in MySQL8, possibly all, I think it's a lot, I don't think it's all, it's just a set of views on top of some internal tables. So it doesn't have that overhead thing that I was describing where it's really quite nasty for fast changing metadata. No, it works quite well in MySQL8. Explain extended. That was a question from Shlomi. No, did I cover it? Okay, we'll skip that. All right, let's show another example. And I think I'll just go back to here. Okay. So we haven't looked at memory usage yet, have we? And we haven't looked at statements. So I actually think statements is a little bit more useful. So let's cover statements next. So we know there's already select star from sys.statement analysis, which will give us a summary ordered by our aggregate time for that particular digest. I'll show you another one that I like, that there isn't a sys view for it yet. Maybe there could be. And this is to find the most recent queries. So let's say that we did a deployment and things started getting slow. Well, it might be that we have new queries that have just started happening on our system. So how could we tell that? We could ask Performance Schema to basically just give us a summary of the 5 most recent queries. And it turns out I'd never run show engine in ODB status on this system before. We could also do, if we wanted to, you know, above a threshold of a minimum time await of being some number so we don't get too much noise. But this will tell me my 5 most recent queries. And I ordered it by recentness. I could also order it by some other metric and recentness if I wanted to say that it's at least within the last hour. What's the most expensive? But you can kind of see how that works. I'll let you create your own queries. The main time information, as I said, is in picoseconds. Count star tells me how many executions of this particular query we have done. And now this is my most recent query. So this is interesting how live it is, right? I think before we had this statement level information performance schema, in many cases we were turning on and off the MySQL slow query log, and we don't have to. I think there's still a lot of value with that. I think it gives you a longer analysis over a larger time window, particularly if your workload has some cyclical aspects. It is useful to have that, but this is immediate, which you know, can help in that deployment scenario that you've immediately had something to follow up. And you can see some of the main pressure points around what can make a performance, the performance of a query slow. Okay, let's look at some other ones. So that was most recent queries. This is most expensive queries. This is actually very similar to the sys statement analysis, but I want to show you one modification to it, which is to use this funky syntax. If you're not familiar with it, this is called a window function. Window functions are a new feature of MySQL 8. So this
Morgan,
one
while
will,
you are on that screen, something you didn't say, but that's very nice, is the query sample text that you have in MySQL 8. Just there on the screen now.
That is true.
It is something new, but I think very, very useful for people to know.
Yeah, I'll point out a couple of other things. Thank you, Fred. So this is basically the latest and greatest. But what's new is that in prior versions, you used to only get an average time for the query, a minimum time, some time, and a max time. You now get a P99, which I love. I think that's a way better metric. And you also get a query sample. So this digested form, you can't run explain on that. It just won't work. Explain needs values. But this will show you the first occurrence that it saw of this until the timer expires, which is configurable. And that you can run through explain. So, and it'll also tell you when it found that sample. So thank you, Fred. I do think that is a useful, worthwhile feature to point out. But I'll jump back to this and I'll show you my example with the window function. I think why this view is particularly nice versus Sys's view is that it will tell you the percentage of time that was spent on this query. So this was my top query. It was a delete query. It's blocked because actually it was spending a lot of its time on lock wait, I think. But it tells you the percentage of time. And so when you're thinking about what to optimize, I always like to, apply Amdahl's law. If it takes 90% of time, then if I make a 50% improvement, I can guarantee, close to a 50% improvement on the full system. But if I see that this is only like 10% or less, I'm less enthusiastic about trying to find optimization in that item, right? Because the global return that I'll get is far diminished. So you could do this through some other query, but I think this is kind of the magic, very simply, of using a window function to be able to say, what's the sum over the total set? So a window function, it's like a group by, but the rows don't collapse. And here we've been able to see in this particular example, which I captured at some other time, this query was 9% of time. So it kind of falls in that area where I do get less enthusiastic. I love when I log into a system and it's some top query that's 20, 30% of time. And it's also easier if the total system has 50 digests rather than 5,000 digests. It makes it easier to find targets. Another thing that's new in MySQL 8 is histograms. So as well as these P99s, you can get a breakdown per digest in this performance schema table that's called histogram by digest. So let's just select from the table first so you can get an idea of what it's got. It's a little bit raw. It's a little bit hard to be able to do anything actionable from it because it has these digests, and it has a bucket timer high, bucket timer low, and it's power of 2 buckets. And there's, I think, thousands of buckets per individual digest. But what I like to do is I like to group it. And there's some other queries, I'll get to them in a second, some other questions. What I like to do is group it into sort of base 10 numbers to be able to get a summary. So here's my same statement information where I'm grouping it into a histogram so I can do some ASCII art. So I'll show you that example, and then I'll answer the questions that we have on the phone. So we can see this is my top query version comment because I've executed it 6,000 times. And we can see that the execution time is a histogram. Unfortunately, these are not currently ordered, is that most of it was in the 10 plus microsecond range. And then there's some that were in the 100 plus microsecond range. I love this data, particularly in the case that in the prepared statement form, it doesn't show you the values. And you may have some queries that are split between a few different query plans. And so it makes it hard to be able to identify that there's part of the query that's performing exceptionally bad, perhaps because of a logic misunderstanding by the developer. Like you might say select star from orders where order date is greater than yesterday or order date greater than the beginning of time. And there's this really large performance disparity between those queries because the first one may use an index and the second one may have to table scan. Okay, let's get to the questions on the phone. So feature request from Morgo, add the locking information you showed to MySQL shell check extension. Thank you. Yeah, I can do that. I actually think it's useful maybe to add to sys as well. I think one of my sys ones is the metadata one is a feature request that's on bugs.mysql.com. The data locks one is not. I think I should do that too. So I will chat to you after, Fred. And the question from Andy is, statements is on by default since MySQL 5.7. I think statements is actually on by default since 5.6 even. I think it goes back even further. And you can get some information at the statement level very easily in MySQL 5.6 and above. As I said, the one thing that I don't necessarily like about it, or maybe the two things, is that you only get the prepared statement form. You don't get that sample that Fred pointed out. And you don't get a P99. You get a minimum, max, and an average, which is a little bit rough. I love the P99 and I love the histogram. I think that makes it so much more useful. So we've probably got about 10 minutes left, and then I'll try and finish up. I think I'm down to one more example in my feature request, but Shlomi, question.
Yeah, I was wondering about the memory consumption of the statements digest, because we've had experience where we'd run Vivid Codex and then we'd run encryption, and then we'd tell Vivid Codex, please ask performance schema about the queries instead of listening to them yourselves, and then we crashed our servers because
yes,
too many queries. So how do you mitigate that? What do you do? What's the correct way?
What version were you using, first of all?
5.7.26, I guess.
Okay. Let's go back to my notes between versions. I forgot to go back to that. So performance schema is all in memory. So there's obviously some memory pressure as part of that. There's no built-in archive. worth noting, you may only have a few minutes of statistics for some important numbers. What I think is interesting to point out by the versions is that 5.6 was the first to enable it by default, but a lot of people have complaints with how much memory performance schema has in 5.6. And there's a simple reason for it. It allocated all the memory it would ever need in advance, and then it would never have to allocate any more memory. And this could be quite a lot if it never had to use that on a smaller server. So 5.7 changed to a better model, which was it allocated a chunk of memory up front, and then if it needed more, it would allocate another chunk of memory. And it tends to be much better. In both cases, it doesn't free memory. I'll point that out. It does take some overhead in memory to be able to keep this fast and not constantly doing malloc, which is kind of the goal of having a production level monitoring system. But getting to your point, Shlomi, I think one of the really interesting things in MySQL 8, which makes performance schema better, is it has indexes. So performance schema, it's implemented as a storage engine. It actually doesn't truly have indexes. It lies and basically advertises that it has indexes, and then handles the filtering when it gets requests from the server and how to execute the query. But the net effect of this is that you get much better query execution plans in MySQL 8 than you would in 5.7, where they can be really quite off because it can't effectively plan when it doesn't know which order to join the tables for where it can eliminate work. And so I know that, on a system with 1,000 connections, if you did something like select star from sys.session, on 5.7, maybe it was a bit more than 1,000. It could be, 20, 30 seconds to execute that query. And on 8.0, it's less than 1, just because it's joining in the correct order. Does that partially address your query? I do think it's a known issue to execute those queries in 5.7. It does get much better. So try again. Okay. So I think now I have covered the main things that I wanted to cover here. I want to mention one more, which is that not all instruments or consumers are enabled by default. If you want to get more detailed statistics, you may have to enable some, and you may have to enable some in MySQL 5.7 in particular. I don't like the set that's included by default. I really wish that these two extra ones were on. I'll show you my last example, and then we'll open the floor, and I'll cover my feature requests as well. I don't think I covered this, which is, where is my memory going? This example is actually in the MySQL manual now, but this is what did I do wrong? Near current alloc. Oops. Maybe I'll have to skip that. That's the risk of doing examples, but let's try the second one down and see if that works. I don't want to live debug too much. I think that'll cause other problems. But this will give me a summary. Maybe that's near current. Current might be a reserved word. Did I get that right? Because the query otherwise looks. All right, that's right. Okay. I have a 5.7 server, and I have instrumentation turned on. Let's see if it works. No, it doesn't. Okay, sorry about that. Other questions? Select count from information schema dot keywords were reserved. Yeah, that's a good point. 2 parents after format bytes. Thank you. All right, you saved me the live debugging. Two parents. Well, that's a sum, so that's correct.
Yeah, that's the
But
sum. I see that now.
Okay. Let's simplify the query just a little bit. You might have a higher chance of running. I'm stumped. I mean, that looks like it works for me. Sorry for the live demo fail. We're kind of running out of time there, so I will. I'll go to my feature request and say where I think that performance schema could be better. I first said the thing that Shlomi mentioned, which is it would be nice to have more perspectives from or consumers from the transaction view. It'd also be nice to see from the user view. So you can see that, you know, in sys and in performance schema, there are tables where they've got a summary like user summary by statement type, user summary by file IO. But I think that there are more aggregations that you could do. Like maybe I want to see the digest that a particular user is executing. Because maybe I have a multi-tenant application, I give each tenant a user. I think that that might be useful to some people. I know that there are some large deployments of MySQL that prefer to have a multi-tenant sharded system where they have one cluster rather than they have hundreds of clusters, because it just ends up being easy to manage. I think it would kind of account for that use case better if there were more consumers from the user perspective. Another thing that's kind of interesting when you compare performance schema to, you know, slow query logging that you know a lot of people have historically used. I would love to be able to say that I want all of my sessions instrumented with performance schema at the default level, which, as I said, is probably about 5 to 10% overhead. And then I want to roll the dice and say 1 in 100 sessions. I want that to be exhaustive. I want to have as much instrumentation as I can. And then I think that might help me find some other problems. You know, let's say I'm throwing out rough numbers, but let's say if it was 30% overhead, if I enabled everything, I think that would be reasonable to do on a 1% basis if you could get some additional metadata. I have a feature request that performance schema, I didn't point it out, they use a thread ID, whereas MySQL uses a connection ID. It'd be nice if the rest of MySQL kind of adapted to this thread ID. So you could say kill thread ID and then the performance schema number rather than having to map it back to MySQL process list ID. And I'd love to see, you know, the underlying hardware that I have on my system, how many cores, how much memory, because I think if you expose that in either performance schema or information schema, it would allow auto tuning. So I could basically tell in a monitoring tool that someone's allocated the wrong size to their InnoDB buffer pool. And I think there is a market for monitoring tools to use performance schema. I have a bit of a nit that not all of them are using it. I know PMM makes pretty good use of performance schema, but I think for some of the others, they want to have something that works with all MySQL versions and flavors. And so they don't tend to use performance schema as much as they should. Also, users don't necessarily ask for it. So we're kind of kept a bit back at looking at query cache hit ratios and other shit that's really not useful. And I would love to see some sort of representation of explain or execution plans. I think this is missing inside of performance schema. And I think that this will become important as MySQL moves into the future and adds more optimizations, and probably we'll have to add something like query plan binding and query plan caching. it'd be really useful to see. As I said, I use the histogram currently to try and detect that a query is stuck between two digests, but I would love to see that in a internal representation that's normalized.
You already have the CPU information available, but you need to enable it, Morgan.
Really?
Yes.
I didn't know. When was that added? So I can see how many cores my system has?
I think so. It's MySQL 8, of course.
Okay.
You can see also you can see the number of cores and the percentage MySQL is using.
Okay. That helps. Can I see memory? Like total memory?
Let me check.
I never stop at that one, right? I need both. Well, yeah, thank you, MySQL team. That is. Oh, you get it from InnoDB metrics. Okay. Okay, then I have another request. Let's put it in performance schema. Not InnoDB metrics. That's nice. I didn't know that was there. If it was in performance schema, it's going to be a more normalized view, which makes it a little bit easier to work with. But I'm going to work with that. I like it. Just check. There's no other comments. Any other comments as we wrap up? Have a couple of minutes spare, and then I'll turn the recording off and we'll chat about what to do next. Awesome. Well, thank you everyone for joining, and thank you for the questions. We're going to stop the recording now, and then we'll
Thank you very
chat.
much.